Okay, more on rational functions. Remember, rational numbers are any numbers that can be represented as a fraction. So a rational function is a function that is represented as a fraction. Now traditionally, and I'm going to be crazy and call it N and D, you're going to have one polynomial in the numerator and the other one in the denominator. So I'm putting numerator on top and denominator on bottom. Both of those would be, N of x and D of x would be polynomials. Okay, now knowing some really good features about polynomials and rational functions, we can find a lot of information very easily. Now, we talked about last time finding our x-intercepts. Now remember, x-intercepts on any functions occur when y is 0. Now remember, if you're talking in function notation, that means when f of x is 0. Now, since we have a fraction, in fractions, this only occurs when the numerator is 0. So you would set the numerator equal to 0 and solve for x. Very simple. Now, the next key feature on any graph are your y-intercepts. Now, y-intercepts are pretty easy to find as well. Y-intercepts occur when x is 0. Well, that's easy on anything. Plug in 0 for x. Now, a note here, why do you always only have one y-intercept when you have a rational function, or when you have any function? But you can have multiple x-intercepts. Well, the thought there is, to be a function, each input value has only one output. So when you plug in 0, you should only get one output value. That's why there can always be only one y-intercept. Now, the other key features of rational functions are vertical asymptotes. Now, we introduced those last time. Vertical asymptotes occur when you divide by 0. So they occur when the denominator is 0. Now, if you actually plugged in that number, you get an undefined answer because remember the denominator can never be 0. So one thing also, when you find out what x values make the denominator equal to 0, you also know your domain. Your domain of these functions will be all real numbers except what makes the denominator 0. So let's underline that word except for those values. So let's look at a few examples here. Example 1. F of x equals 3x minus 4 over 2x plus 5. Now we're going to find each of these key features. The x-intercepts. X-intercepts are found by looking at the numerator. So what would make the numerator equal 0? If I set it equal to 0, I'd have to add 4 and then divide by 3. So I get, 4/3, 0. Now, to find the y-intercept is found by letting x equal 0. So if I plug in 0 for x, 3 times 0 is 0, minus 4. So I'll just have a negative 4. That'd be 0 plus 5. Hey, anything with an x would be 0, right? So I can almost cover this up and see what's left. Negative 4 over 5. Ooh, the y-intercept's easier than I thought. Now, vertical asymptote. It is found by figuring out what makes the denominator equal 0. So what would happen if I set 2x plus 5 equal to 0? Well, I'd have to subtract the 5, so I get negative 5 and then divide by 2. So x equals negative 5/2. Now what's beautiful is the domain follows straight from that. It's all real numbers except negative 5/2. Next example. Example 2. F of x equals 8 over x squared minus 6x minus 16. All right, so the first thing we're going to look for are x-intercepts. Our x-intercepts are whatever makes the numerator 0. I don't care what I plug in. Can I make 8 ever equal 0? No. So this one has no x-intercepts. The y-intercept occurs when x is 0. So if I plug in 0 for x, all of these are going to go, and I'll be left with 8 divided by negative 16. That's negative 1/2. Vertical asymptote. The vertical asymptote occurs when the denominator equals 0. Oh gosh, it might be helpful to factor that. I'd get x and x, negative 8, and a positive 2. So my vertical asymptotes would be x equals 8 and x equals negative 2. Remember, those are two vertical lines. That means my domain is going to be x is not 8 and x is not negative 2. Easy. Number 3. F of x equals x plus 6 over x. All right, so one more time. X-intercept is what makes the numerator equal 0. It's easy, that's negative 6. Y-intercept is what you get when you plug in 0 for x. So I get 6 divided by 0. This one does not have a y-intercept. That's okay. Next, vertical asymptote. It's whatever value makes the denominator equal 0. That's easy. So my domain are all the real numbers except for 0, which is why we didn't have a y-intercept. F of x equals x plus 6 over x squared plus 4. Okay, so x-intercepts are whatever makes the numerator equal 0. X plus 6, that means I get negative 6, 0. Y-intercept occurs when x is 0. So if I plug in 0 for x, I'd get 6 over 4. That's 3/2. Vertical asymptote is whatever makes the denominator 0. Now I know if this was a difference of squares, I could factor it. I can't factor that, so let me go off to the side and say, well, okay, what's going to make x squared plus 4 equals 0? X squared equals negative 4. Can something squared ever be negative? No. So this one actually has no vertical asymptotes. It happens that way sometimes. So that means if I don't have any restrictions on my x values, then it's all real numbers. Remember, you can do the fancy r, you could do negative infinity to infinity, whichever one you prefer.